So right now, actually, I'm working on a subcontract with Cornell on this very large SCRI project that Terrence Robinson is leading. If you're interested, you can go to pacman.extension.org and find out about that project. But we like to say that apple crop load management is probably the most important spray. In other words, your thinning spray that you'll do all year. Forget the insecticides, forget the fungicides. That stuff's all easy. Doing your chemical thinning and getting the appropriate crop load is probably the thing that's going to affect your profit the most, and probably one of the more difficult things. So over the years, thanks to Dwayne Green, who came up with this fruitlet growth rate model, and just briefly, I'm not going to tell you all about what the fruitlet growth rate model is, but I've been using it to measure fruits. I've been focusing on Gala, Fuji, and Honeycrisp, because those are the three most popular apple varieties right now. Forget Macintosh, forget McCown, forget Cortland. No money in those, but there is money in these other three apples. I'm not sure it's worth taking the time to do crop load management on those apples, but he's gonna. Anyways, I'm just kidding. You know me, I kid a lot. But I've been working with Gala, Fuji, and Honeycrisp. I've been marking clusters in the commercial blocks, or actually been mostly working in my blocks in the spring. Measuring the fruitlets as they're growing and trying to predict fruit set. And have been pretty successful with that. Getting growers to do that, however, has been more difficult, as some of you may know that I've worked with trying to get you to do that. So what's coming on the scene now, rather than have to measure the fruits and enter the data manually with a caliper or whatever and marking all these clusters, I started, and this whole group, this Pac-Man group, is also using robots and trying to develop the visualization of the canopy and what's in the canopy in terms of fruits is becoming very kind of the end thing to be working on in this field in terms of precision crop load management. And here on your handouts, I've been working with several of these companies over the past year or two, and then Paul's going to talk a little bit about the collaboration we got going with Carnegie Mellon on this. But I wanted to point out, this year I was working with Farm Vision Technologies. Paul, can I have the T thing? This is a unit that they will sell this. They rent or lease it. This is the unit they're using though to visualize the canopy. Okay, it consists of a very accurate GPS unit, a cell phone with their app on it, an Android cell phone with their app on it. It's got a battery pack down here. And how this works is basically I can scan the canopy. There's what kind of camera is this? Multi 3D camera?
It's a stereo.
Stereo camera. Same thing as CD.
Yeah.
Stereo's 2D.
No, 3D.
Stereo's 3D? No, it's
If
not.
you see in one eye is 2D. Two-dimensional.
Okay, the point is, I can take this now and been working with them. I've got some plots set up here. You maybe see some of these cards on the ground. And for the fruitlet growth rate model, when the apples were small and trying to get an estimate of crop set, I would scan these 5 trees kind of like this in an up and down fashion. Upload the video when I get back to the office to their cloud-based website. And then you can see on your handout the results, kind of what it starts to look like. They can predict, believe it or not. I was skeptical. I haven't evaluated all the data, but it looks pretty close. They can tell me basically the results of the fruitlet growth rate model, and they're looking at a lot more fruits than we can measure. They can predict and precise, okay? Other thing is, the other company I'm working with is Fruit Scout. I'm going to go over a little bit, Jaime, because this is the most important thing today. Paul, hold this. Can I get the Fruit Scout thing?
What do you want? Oh, you want this.
I've also been working with this Fruit Scout company, not quite as successfully, but they have a way of taking cell phone pictures. You just use your cell phone. They can measure the trunk, because you know the trunk is kind of a capacity thing about how many apples should be on your trees. They take a cell phone with this up against an apple, and they can do the fruitlet growth rate model too. And I've just started working with Pixel Farm and Crop Tracker. Crop Tracker, some of you are using for your pesticide record keeping. But they also have yield prediction, fruit size, and bin scanning, which I'm going to start to work on when I get a chance. Okay, Jaime, I think that's it. You can kind of see the charts there, some of the output from the Farm Vision. I'm really impressed with them. Give them another year, we'll see what happens. Okay, hand it over to Paul.
Okay. A few years ago, we came up with an idea that we could use imaging and cameras to actually solve the thinning problem. There was imaging in larger apples, but that's a much easier problem to solve. So we talked to Carnegie Mellon. Dan, I'm from Dan Cooley's lab, I should add that first. And Dan has some colleagues at Carnegie Mellon, and we suggested the problem to them, and they thought it was a good idea. They have an excellent robotics lab there. And so we wrote a grant. We were lucky enough to get it, and we started the process. I believe we were the first people to use these tags now that you see everywhere. We didn't come up with the tags. That's from University of Michigan, but we're using them in this regard, and this allows robots to actually be able to see in 3 dimensions in a certain way. And so what we have come up with is similar to what these other groups have done, except it's more precise. So we started off with a big camera, like really big, a few years ago, that would come around on a tractor, basically, and we would hand image the clusters. We were to the point this summer where we've got a handheld camera, kind of like, well, I don't know where John had the little stereo camera, a little bit bigger than that he was showing you. And essentially what we can do is we can aim at a cluster, and right now it takes about 6 seconds, and we can get measurements down to below a millimeter, so within, say, half a millimeter. So what we could do, and by next summer the goal would be, that should be instantaneous. So you take a picture, the computer recognizes the apple fruitlet, and it tells you the measurement. We can then feed that into Dwayne's model. What we're actually thinking of doing next summer is seeing if we can perhaps pick 5 trees, get measurements, just quickly scan each side, wait a few days after you've applied the thinner, go back out, scan a couple more, and because it can measure so many clusters, we may be able to get our results right there. And it would either be on, probably not a cell phone itself, but a little camera we could attach, just plug into a cell phone. We can do it robotically, so if you have a lot of acreage, and that seems right. Carnegie Mellon actually on their end is they have a robot that will drive. It will find the cluster, use the arm, take the picture, do it all automatically. You don't even have to leave where you are. So I think that's about it. Questions?
Are you measuring